Okay, the microphone's on this, so let's give this a shot. So what I'm actually going to be working on here today is the 4.5, 4.8 review. And I'm going to try and go through this as quickly as possible so that the video doesn't turn out to be super long. So a couple of key things to keep in mind when you're looking at for the unit test that you're going to be taking, multiple choice and free response. Most of it is non-calculator. I mean, how often are we using the calculator in any way, shape, or form? Pretty much never. Okay, so be aware that that's kind of things we're looking at. Some key ingredients, I would say, when it comes to the graphing, you're definitely going to be wanting to graph sine and cosine, and even secant or cosecant. And also be aware that you're going to be seeing some tan and cotan graphs, okay? Big things to remember about sine and cosine, secant and cosecant is definitely the way that we find the period, which is 2 pi over b, and even finding that gap amount, which is the period divided by 4. So we've done this so many times that it really shouldn't be that big of a deal. And you should be able to take a picture like, say, this following one right here, say 2 sine of 2. Notice that the 2 is outside. This is a good place for it because it actually indicates where the actual phase shift is going to end up being, and as well as the vertical shift back here in the back. So you should be able to, just like we've done on all of our individual quizzes, be able to find the amplitude, the period, which is 2 pi divided by 2 in this case, or pi. Give yourself the gap value, which is going to be pi over 4. And you should also be able to find the phase shift, which in this case is pi over 4. And the vertical shift, which should end up being positive 1. Okay, be aware we might also be asked for a domain and range concept. So I'll show you those two ideas once we actually get done graphing this one. So vertical shift is going to put this graph up 1 full unit, is where the midline is going to be. Now keep in mind that when we talk about midlines, we're going to also be talking about a horizontal line. So if they ask you that, make sure you dictate that it's a horizontal line as y equals 1. Also, since this is a sine graphs start at the origin, and that origin concept should give us some indication of where we should go with this. Also, vertical shift is going to push this, hold on just a second, not at negative pi over 4, but it's going to actually push it to positive pi over 4, so it'll end up being over here. And this is where we're going to end up starting our graph, is at this location. Now, if our gap amount is a pi over 4 amount, and our amplitude is 2, we can expect that each one of these individual tick marks will be a pi over 4 distance, and we should ultimately be able to graph a sine wave that looks like the following. Okay, keep in mind, you should definitely be noting that the actual graph is continuous and that it turns at these individual points right here. Don't make it look like it goes down or they're rigid or it's sharp. They are nice, soft, curved graphs, okay? Domain, every one is going to be from negative infinity to positive infinity for sine and cosine, and the range is going to be dictated by being between the two amplitude points, which is from -1 to +3, okay? Now, we've done so many of these that ultimately this part should be pretty second nature to you. So I don't think it should be a huge issue to take on, okay? Now, my focus would probably be to make sure that you have a much stronger technique when it comes to doing, say, a secant or a cosecant, because these graphs are a little bit more involved and specifically in some of the dimensions that you've got to find. Okay, first off, make sure that you change it into a cosine graph. Yank out that b value so that you don't have to worry about finding that phase shift correctly. Okay, and that will automatically help you with all the things that are here that are necessary. Amplitude is 1. Period is going to be 2 pi divided by 4, which is going to be pi over 2. You'll get a gap amount, which is really super tiny in this case, which is pi over 8, because you're dividing by 4. And then we'll go down the actual ideas here of phase shift, vertical shift, domain, and range. Now, I'd watch out for these two at the end because they're easy ones to miss. So be careful there. Phase shift, negative pi over 4. Vertical shift is 0. So I think we should be in pretty good shape of graphing this inverted cosine, which is going to start low and come back to its low point when you start here. So amplitude of 1, phase shift of negative pi over 4 is going to start it over here. Every pi over 8, which is halfway in between these two, is going to be the other part. So this is where the actual cosine graph is going to lie. Now make sure that when you get done here, you're checking this against the actual period, because if your length isn't what you stated in your period value, then you did something wrong and you should check it. Make sure that you do it correctly. Okay, now when you do a secant or a cosecant, everywhere it crosses the midline is where you're going to generate an asymptote. So make sure you show enough of these that you can show at least at one up and one down, which this one's going up and this one is going down. Okay, now domain and range of this, just to be sure you're getting what you should, you'd want to say x cannot equal, and we're going to get the very first asymptote that's there, which happens to be a pi over 8 asymptote, plus half of the individual period when you do these for the pi k parts. So that would be half of that would be pi over 4k is how far you have to go. And that makes sense that you're traveling at least a pi over 4 or 1 tick mark. The range would go from negative infinity all the way up to the lowest point of the first one, which is negative 1, unioned with 1 to infinity. Okay, watch these guys. They're really easy pieces to miss. So I definitely would be focused on secant and cosecant. That's the parts that I'd be thoughtful of. Okay, next part down, number 3. So the upper part was really about studying your graphs. Make sure you understand what's going on there. Period, frequency, phase shift, range. Make sure you know how to find all these individual pieces. Frequency was one that was talked about in 4.8, and that was the day that I was gone, so I hope you caught that off of the actual video. To find the frequency, you take the period and put it on the bottom of 1 divided by the period. So keep that in mind if you're looking for those kind of questions from 4.8. Period in this particular case would end up being 2 pi divided by 9, because that's the b value on the outside. Phase shift in this case would be positive pi over 2. The range of the answer is going to be dictated by the actual amplitude. So this amplitude is 1, so it'll go from negative 1 to 1. And then last but not least, that frequency is going to be 1 divided by the period, and all it really does is takes the period and it flips it over. So this is 9 pi divided by 2. It's because you're doing an inverse relationship or an inverted reciprocal relationship. That's why it just flips the actual value over. Okay. Number 4, same kind of idea. Period is going to end up being equal to 2 pi divided by 9. I should probably write this as 9 times x minus 1. So you've got the b value. Phase shift would be a positive 1, whereas the range on this guy is going to be dictated by the amplitude, which is negative 2 to 2. Again, frequency is going to take this value, and it's just going to flip it over as 9 pi over 2. Okay? Now, when you get down here to a secant question, be a little bit more careful and more thoughtful of what you're trying to accomplish. Getting the period and so forth, it still works the same way. 2 pi divided by 2, which is going to make it pi. The phase shift has been pulled out correctly, so you can see it as negative pi over 5. And then you're going to be getting a range answer. Now, this range answer, since you're dealing with the ups and downs, is going to end up being from negative infinity up to, and it would normally be the amplitude, but since this has been raised by 1, that means the lower end of it is going to be at -7, and the upper range of it is going to be 8 units higher than 1, so that's going to be 9, and it goes to infinity, okay? Again, if I wanted to find the frequency, I would just take the period and go 1 divided by that, and that is 1 divided by the period, okay? Okay, a little practice there. If you have to go back, take a look at those, definitely do so. Number 6, writing equations backwards, okay? Now, writing equations backwards is not really overly difficult, but you just got to watch for details, and specifically the one detail that most people miss is the full length of the period. So watch out for this. This is the one that usually people miss when they're trying to find the b. This starts low, returns back low, so this must be an inverted cosine. So a negative cosine. I've got to look at the amplitudes from the midline, and the midline amplitude is 5. And then it's not been phase shifted because it starts at the actual y-axis. So there's no phase shift here. So I'm going to put an X there, and the midline is still at 0, 2 as well. So it doesn't have any vertical shifts. So the big key here is to find B. And that's the part that most people struggle with. You want to take the B formula, the 2 pi divided by B, and you want to set it to the length of the period that you're seeing in your picture. This case, you would cross multiply, but this one's pretty easy in noting that B would turn out to be 3, and there'd be your formula. Okay, so pay attention to those little tiny bits of detail. Okay, now we'll do that same concept again here. We're going to first look right at the actual length of the period, which is 6 pi. So that's going to be something we got to pay attention to when we get our B value. Again, starting low, ending low, an inverse negative cosine with an amplitude of 3. The B value is going to be 2 pi divided by B is equal to 6 pi. And this is one's probably worth cross multiplying, as 6 pi B is equal to 2 pi. And if I divide, I'll end up getting that 6 pi over here, and I'll end up getting 1/3. So this is going to be a 1/3 X with no difference in the actual vertical shift. Okay, number 8, sine wave graph. Starting here, ending there. Period length that you're seeing in that is pi over 3. So that's going to help us find our B. Sine wave that's in normal situation is 6 in amplitude. So make sure you're paying attention to the size of that amplitude. The B value, no phase shift, but the B value would be 2 pi over B is equal to 1/3. Or pi over 3, excuse me. That's 2 pi, 6 pi is equal to pi b, so the answer here would be a 6. Now, the only thing different here is to note that that is a 6, so it's been moved up to 6, and this is the devil graph. Because it's got 3 6s in it. Okay, scary. All right, last one that I'll do down here, number 9. Ultimately, full length of that guy is 4 pi. It's definitely an upside down cosine graph. So y equals -3 cosine for the amplitude. 4 pi, so 2 pi divided by b is equal to 4 pi. Well, the only way that's going to happen is if I use b as 1/2. No phase shift and no vertical shift. Okay, now none of those graphs had a phase shift. They all started at the y-axis. So again, remember, go from trough to trough or peak to peak. Make sure you get a full period out of what you're looking at, okay? Now, on the back page of this, it says be able to graph the other ones that you want to be able to do, and that's the tan and cotans. And they really exist in their own realm because of the techniques we use to do it. Number 1, make sure that you're dealing with pi over b. I do not like this gap formula. We will still use pi divided by 4 because there's still 5 critical points on an actual tan or cotan graph. The key ingredient you're going to have to remember is to put that b times x minus c part between your fences. Now, if you're talking about a tan, it's going to be stuck between negative pi over 2 and pi over 2. Okay, if you're talking about a cotan, you're going to stick those things between the fences of 0 and pi. Now, the reason why I do it this way is because ultimately it will give you the asymptotes on the left and the right, and you won't have to worry about phase shift. You won't have to worry about the size of the period. You can ultimately lock it directly in, and you'll get what you're trying to do, okay? Now, start out here in the beginning. Make sure you pay attention to some little details. And a negative tangent would ultimately not go uphill. It would go downhill. So pay attention to that. That's going to make a difference in which way you graph your deal, okay? The 2x that's right here is going to get wedged in between the two normal wedged values that we would normally use for tangent. And this will ultimately give me the x answer that I'm going to get in both directions for the two asymptotes. Now I'm going to have to divide this by 2 or multiply it by 1/2. So that's going to be negative pi over 4 and pi over 4. And that automatically gives you the two asymptotes that you're going to be basically looking at. And you can verify that the period works out the way that it should, because it should be pi divided by b, which is 2, and the answer is pi over 2 in size, okay? Now, all the other little pieces fall into place here. You get the point that goes, goes in the center right there. You get an amplitude point here and an amplitude point there, and that graph is just going to go downhill, okay? And that's as easy as you can make these, is if you actually just understand how the fence category works, you can easily lock in the correct location every time, okay? Now, I am a firm believer that this piece that you're looking at right here shouldn't be written with the B on the inside. You should always try to pull this so that you can easily identify the phase shift. But ultimately, it really won't make any difference in your graphing as long as you're just taking that 2 times x minus pi over 2 and putting it between the correct fences. That would be 0 and pi. If you're hearing Isaac screaming in the background, that's because he's playing Valorant and he is a wussy when it comes to getting chased around. Okay, so this is going to be 0 is equal to x minus pi over 2. And that 2 on that side, if I divide it out, is going to be pi over 2. Now add. We're going to get an x going in one direction of pi over 2, and we're going to get an x in the other direction as of pi. And that easily locks the graph into the right set of ideas, and the period would be in between here, pi divided by b, which is pi over 2. And look, it's exactly the size you want it to be, okay? Now, if you just go with the shape of a cotangent graph, which normally goes downhill, it's going to lock in right here, but this amplitude is only 1/2. So it's going to be relatively small in there, as that amplitude is a small amplitude. Okay? So be careful of what's going on there. Now, both of these graphs, the one thing that tends to give people a little bit of grief, especially when they're asked to do it, is to write their domain and to write their range. The ranges, since they go to negative infinity, infinity, are always going to be the same. They both go up, they both go down, no big deals. Okay, the other one is going to be dictated by what's the first actual asymptote you see on the positive side, which in this case is pi over 4, and then it's going to be plus the full period k, so pi over 2k, right? That's how you'd write that one. This domain would be x cannot equal pi over 2 plus, and that is another pi over 2k for the period. So no big issues there. You just got to practice a little bit, guys. Go back to your actual stuff. make sure you know what you're doing, okay? Excluded values, period, phase shift, domain. Okay, that's kind of like, you really don't even need to graph it. You can come up with a lot of these things. The 3 taken out is x minus pi over 3. That's the part that I really need to pay attention to. Amplitude won't make any difference. Phase shift is already in there, so phase shift is equal to pi over 3. The period is going to be equal to pi over 3, which is really bizarre. And then last but not least, the domain would be the first. Now, you would have to do the fences on that, but you could think that the first deal is a positive pi over 3 and it's cotan. It's going to actually move the asymptote to pi over 3. So this is actually x cannot equal pi over 3 plus pi over 3k. And what I did right there is I thought about the cotan graph, and the part that's really being phase shifted is the leftmost asymptote. If you don't understand what I'm doing, draw yourself a cotan graph, and you'll see the part that lands on the y-axis happens to be the left asymptote, okay? This guy here, phase shift would be 0. The period would be pi divided by b, which is 2. And again, a cotan graph that's not been phase shifted, so the domain in this case would be from 0 plus pi over 2k is what it would be, okay? A tan graph, on the other hand, when you draw the tan graphs go uphill. It's the actual origin that's going to get moved in terms of the phase shift. So these are a little harder because you got to figure out where the first asymptote is. And I would almost suggest put it between the fences, and it'll help you figure out what you're trying to do. Phase shift in this case is negative pi over 4, because it's going to be shifted left. The period is going to end up being pi over 4. And the domain, oh crap, that's going to be hard to figure out. Okay, so it would normally be at, well, the fences move them in. I'd have to put that in the fences, guys, and I'm not really, it won't be that hard. You won't have to do that unless you actually had a picture to rely on, okay? I wouldn't do that to you. That's just mean. These are like the multiple choice questions that you guys have seen on the last quizzes where you're just trying to evaluate it. These answers are really just going into here, and then you're just evaluating what that is. So it's really actually trying to evaluate 6 times tan of pi over 2 times 6 is 6 pi over 2 or 3 pi. Let me think about my math there for a second. 6 pi, yeah. And 6 pi is really actually landing on pi, and tangent at pi is 0. So it's all evaluation. Now, if you try 3 pi over 2, you're going to get 6 tan of 6 times 3 pi over 2 is 18 pi over 2 is 9 pi, and 9 pi is still landing on pi, so that answer is 0 too as well, okay? So all I'm doing is plugging them in, and then I'm evaluating them. Let's try 16. Cosine of, so this is really 4 times cosine of pi. Is that right? Yep, that's right. Cosine of pi is -1. -1 times 4 is -4. So that's that answer there. 3 pi over 2 would really be finding 4 times cosine of, the 2's cancel, so 3 pi, and 3 pi still lands at pi. Cosine of pi is -1, that's still -4 too. I don't know why these are all the same. Okay, it's weird. Cosecants. Wow, that question of evaluation is a bummer. That is way hard. Ooh, I don't think you'll see anything like that. I'll have to take a look at that one in class. Ask me about 17. I think it just wants some more time to actually look at it. For a set of the following information, write the formula. You've seen some questions that are like this before. Really, the key is I'm just asking, can you put the pieces where they need to go? Amplitudes, of course, go in the front. The period is going to help you find B. That's going to be the part there. And the phase shift is going to go on the actual inside. Just make sure it changes to the opposite sign. The only really hard part here is to take the 4 and set it equal to 2 pi over b for cosine, and you'll end up with 4b is equal to 2 pi. And if I divide by 4, I get pi over 2. So that is your formula. That easy, okay? Watch for vertical shifts or phase shifts. Let's see what we get for this one. Tangent graph of no amplitude. Vertical shift down here on the end is 2, so kind of cross that one out. It did that one. The phase shift is going to go on the inside here, and that inside piece is a phase shift of negative pi over 7, so this should be x plus pi over 7. Boy, that is so small. All right, y equals tan something in the front, x plus pi over 7 plus 2. And then again, we're back to the b value. Now be careful on this one. You're going to have to go 4 is equal to pi over b because you're dealing with a tan. So that's 4b is equal to pi, or b is pi over 4. And you put your formula together. Okay? Sine graph with a range. Now, when we start talking about the range, we actually are going to use that to help us find the midline and to find the amplitude. The amplitude is going to be 2. The midline is going to be right in between those two things, which is 2. The period is 2 pi over b is equal to 7, so 7b is equal to 2 pi, or 2 pi over 7. And then you put the phase shift on the inside here, which is x plus 5 pi over 7. And wow, I made that all so small. So lame. Okay? All right. We're cooking 20 problems in, and I am still here. Woohoo! 4.7, we're definitely talking about inverses. And I can't talk about inverses enough in the fact that they're going to be important later. And just realizing that the cosine inverse exists between 0 and pi is important, and realizing that the sine inverses and tan inverses are from negative pi over 2 to pi over 2. So make sure that when you're doing these and answering them correctly, you just want to make sure you're dealing with the correct picture. Now, I'm not going to make you understand the shapes. I don't think that's overly necessary, but I think there's some disconnect here when you're looking at these graphs, that everybody thinks, oh, that's quadrant 1 and this is quadrant 3. No, that isn't what I'm saying. This is 0. This is pi over 2. This is negative pi over 2. And that is just showing the range of answers that are there. These are called the principal values, from negative pi over 2 to pi over 2. Okay? The answers that they are for their domains that are allowed are between negative 1 and 1. So keep that in mind. You're going to have to know these principal value outputs. That's the key ingredient. You cannot put numbers inside of a sine inverse that are not between negative 1 and 1. This number has to be a fraction of some sort. Now, cosine, on the other hand, exists from 0 to pi, and it crosses at pi over 2, so it ends up starting at 1, going like this, and that's 1, and that's negative 1, and that's 0 to pi, okay? So the domain, again, is from negative 1 to 1, and the deals here are from 0 to pi for cosine. Okay, now the range and domain of these, the domain for this is negative infinity to infinity because the graph goes both ways forever and is asymptotic. But it's making it to pi over 2 and negative pi over 2. So that's its principal values. And please note those are soft brackets because it doesn't make it to the asymptote. Okay? Now, anything that doesn't fall in a unit circle is absolutely, these are just saying, could you plug them in a calculator? These are just calculated by finding the actual inverse. Now, what happens is your calculator recognizes that this is a positive number and knows that it should put the answer in the first quadrant. That's why it gives you an answer that's in that quadrant, right? Where versus in this one, when we do the inverse of the cosine inverse of this, of negative 12/13, it automatically sees this negative and knows that it's going to be placed in the second quadrant. Put these in your calculator and just verify my concepts. And you will be like amazed. You're like, wow, the calculator does know the actual principal and restricted values of inverse sine and cosine. When you do a secant, I'd probably connect this one to doing the reciprocal, then do your inverse. Same goes for the reciprocal of cosecant. Okay. 4.8. This is a topic I didn't get to talk about except for in a video, and that's just modeling harmonic motion. Just to remind you, maximum displacement is nothing more than amplitude, okay? Time required for it to finish, to go from one top to another top. So like say it goes like this. Oh, that's a horrible picture. Say it was a sine wave. Like this. This distance is called the period, all right? Same deal, time required for it to do one cycle. For the cycles per unit of time, that is your frequency, which is 1 divided by the period. And then where does the object start? Now, if it starts at time 0, if it starts high, it's a cosine wave. If it starts at the origin, it's a sine wave. So if we're talking about something like this, those 4 bullet points that I'm basically looking at right there is that the amplitude is 8, okay? The period, which you're going to be doing next, is going to end up being this 5 pi is going to get involved. It's going to be 2 pi divided by 5 pi, or 2/5. That's your period. Your frequency in this case is just going to take that 2/5 and turn it over, because it's going to be take that much time, 5 halves, to get through 1 unit of time. You're going to have 5 halves of the graph is going to happen. You're going to get 2.5 waves. And then the last one down here is where should you start it at time 0? Well, at time 0, it's going to be at -8. It's going to start low, is where it's actually stating that. And that's all these questions are all they're asking, is those concepts, okay? If you do have one that is phase shifted, the phase shift is not time 0. Boy, I haven't seen one of those. Talk to me about this one, because that's one that I need to look at. That's an older question, and I don't think any of those showed up in 4.8 when we picked it. So that's good, worth talking about. 28, down here near the end, find the value of k that yields the phase shift of pi over 9. Okay, so that's our goal. We want a pi over 9 phase shift, and it has already got the 2 inside there. So you should probably write this question out of the get-go with the 2 outside. Well, if you're going to divide it out of x, you're going to have to divide it out of k as well. And since it's negative, it's going to give you a positive phase shift. So you can really say k over 2 is going to end up equaling pi over 9. And you can solve for k. 9k is equal to 2 pi, or k is equal to 2 pi over 9. And that would be the value that would go inside here and would actually give you the correct phase shift for this. Now, that would mean that the formula would be y equals 5 sine 2 times x minus, now you're going to put the 2 pi over 9 on the top of this and divide by 2, which is actually going to be inverted and multiplied. And I think that whole entire thing is going to turn into 2 pi over 18. And check my answer if I got that right, or pi over 9. Did I do that right? 2 pi over 9 divided by 2.
Oh, good try.
Pi over 9. Yeah. So if it's asking for what the answer is for k, this would be the right answer for it. But the answer would be, yeah, I guess 5 sine 2 times x minus pi over 9 is what that boils down to. And it does work. You can check it to see if it actually works. Woohoo! Good job. Now, the only thing I'd be cautious of is if you end up wanting a negative phase shift, that would mean that the formula is going to have to become a positive in that spot right there, which means that the k value you're going to come out with is going to be negative. So try that one out, see if you guys can figure it out. Last but not least, these last 3 questions for 29. Definitely not unit circle, and it doesn't even have a value per se on it. So we have to assume these are drawn in the first quadrant. So cosine is x and 2, making this opposite side here the square root of 4 minus x squared. That's Pythagorean theorem. And then the sine of that picture would be equivalent to the square root of 4 minus x squared divided by 2. And that's how those are done. Just keep in mind this one's over 1. And, ooh, a secant one. That one looks like fun. Let's try that. Drawing that one in the first quadrant, that'd be 4x here and 1 there, making this the square root of 16x squared minus 1. Oops, nope, that's backwards. It would be 1 minus 16x squared. And now I'm wondering if I did the other one wrong. No, I did that one right. Secant, since secant is related to cosine, cosine is adjacent over hypotenuse, so secant must be hypotenuse over adjacent. And I didn't even need to solve that one, so the hypotenuse over the adjacent is 1 over 4x. Pretty easy. Okay? Little practice on that bonus. This is all nothing more than just evaluations. Like, when is cosine 1? Cosine is 1 at 0. So that answer is 0. This one's root 2 over 2. This is 2 times 1, which is minus 2. On this one, this is a plus. Sine 5 pi over 6. Sine is 1, 2, 3. 1, 2, 3. So that must be a half. Second quadrant, adults shouldn't, so that make it positive. So this answer is a half, so this whole thing is 3 halves. And then this is, cosine is 3, 2, 1. So the answer to that is a half. Second quadrant is negative. Adults shouldn't, yeah. So that's a negative a half times negative 4 would be positive 2. So the numerator is figured out that way, and you'd add those pieces together. Do the denominator, and you guys can figure that question out. Okay? I hope the video helps a little bit. Make me focus on parts that you really don't understand, and we'll come back to this.